In this lesson, we're going to talk about how we can prove if triangles are similar. So remember, triangles are similar when all the angles are congruent and when the ratio of corresponding sides is all the same. So if we look and we say that triangle ABC is similar to triangle FED, mark the angles that are congruent. So that's our first thing. So we know that A and F would have to be the same. So A and F are congruent. B and E have to be congruent. And then C and D have to be congruent. Now, if AB is 3, BC is 2, FD is 15, and FE is 9, find and label all sides of the triangles. So the colors make it very easy because now I can look and say, okay, 9 and 3 are corresponding. So my scale factor is 3. So if I look, the ratios have to all be the same. So new over original. Our new was 9 over 3. If we look to find what corresponds to 15, we get that x equals 5. And now you can either use the scale factor and say, oh, 2 times 3 is 6, or we could have solved using the proportion as well. But you should still get that x is equal to 6. Now there are 3 ways that we're going to be talking about proving triangle similarity. So we have angle. If 2 corresponding angles are congruent, then the triangles must be congruent. So if we look here, I have 2 congruent pairs of angles. So yes, we would know that triangle ABC is similar to triangle DEF. Here they only mark one angle, but we also know that these are vertical, so we would also be able to say that triangle VWX is similar to triangle YZX. Again, make sure that you're using the same order of the congruent angles. Now, the other way that we could do similarity is side, side, side. This is different than congruence because we're looking for proportional. So what you would have to do is you'd have to look at corresponding sides. So, for example, 6 over 3 would have to be equal to 8 over 4, which would have to be equal to 10 over 5. This is true because they are all equal to 2, so these are similar. So we can say that triangle QRP is similar to triangle TUS. So again, same thing. I would have to be able to say that 28 over 35 is equal to 24 over 30, which is equal to 25 over 32. You can use your calculators to look at them as decimals. So the first one is 0.8. Second one is 0.8. Third one is not 0.8. So these are not similar because the ratio is not the same. This one is not the same as the other two, so it is not similar shapes. Now the final way that we can prove that triangles are similar is side angle side. So you can, if you have one angle that is congruent, you can say that the triangles are similar if the sides on either side of that angle are proportional. So if we look here, I have my angle. Now I have to check my sides. So I would have to say I have to do new over original. So I'd have to say 15 over 20 has to be equal to 6 over 8. Which is true. So we can say that KLJ is similar to NPM. So for number 6, again, they don't have a angle marked, but we know that the angle is shared, so we do have an angle. So now we have to look and say, is 25 over 15 equal to 21 over 12? Well, 25 divided by 15 is 1.6 repeating. 21 divided by 12 is 1.75, so these are not the same, so these are not similar. So those are the three ways that we can prove that some triangles are similar. So let's look at some examples. All right, we don't have to do all of these, but these will be good practice. So determine whether the triangles are similar by angle, angle. If so, write a similarity statement. So here, I know that the lines are parallel. So if we look at the Z formation, I can use this to say that there's alternate interior as well as vertical angle. So yes, these are similar. So DCE is similar to FGE. I'm following the marks that I made. D and F are both unmarked. C and G have 1 mark. E has 2. So that is my similarity statement. So here I have one shared angle, and because I have a pair of parallel lines, I can say that I have corresponding angles. So these will also be similar. So triangle LPQ is similar to triangle LNM. So here I'm giving a 90-degree angle. And you might say 51 and 39 are not the same, so you can't say that they're similar. But we also know that the total number of degrees is 180. And if I subtract 90 and 39, I get 51. So these actually are not congruent. I'm going to keep doing that. These actually are similar triangles. SYE is similar to triangle WCH. So here we have 68, 54, 68, and 63. I can double check to make sure that my third angle is not going to match either of the other ones. So 180 minus 68 minus 54 gives me 58. So I do not have two pairs of congruent angles, so these are not similar. So here we have 67 degrees, so that is one angle. So again, I'm going to use the fact that a triangle has a total of 180 degrees. So I'm doing 180 minus 91 minus 67 to get that this angle would have to be 22. So no, this cannot be a similar triangle. The last one is because I have a pair marked and I also have vertical angles because of the bow tie. So PXQ is going to be similar to ZXY. So now for side, 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 I have to check that all three sides are in the same proportion. So we have to say 14 over 20.25 would have to be equal. Oh wait, no. See, this is where you have to be a little bit careful. So if I'm looking, 20.25 corresponds to 31.5. So I would have to say that 31.5 over 20.25 is equal to 14 over 9 equal to 21 over 13.5. So I can start checking these. 31.5 divided by 20.25 is 1.5 repeating. 14 divided by 9 is 1.5 repeating. 21 divided by 13.5 is 1.5 repeating. So these are similar. So we would say that triangle KRN is similar to triangle. So we did KRN. So we'll do, I'm just trying to make sure that I label it correctly. So hold on. So we started, so if I was going to redraw this, that would be R, K, N. So it will be D, S, E. Okay, so again, we're going to check 42 over 30 would have to be the same as 28 over 20, which would have to be the same as 21 over 15. So we start checking. 1.4, 1.4, 1.4. So yes, triangle WXV is similar to triangle WYU. So 10 over 16 would have to be the same as 7 over 12. So right away, these are not the same. So if two are not the same, then you can already say that no, they're not similar. Looking ahead for number 11, you're not given information about the last side, and if we're trying to say if they can prove it by side, you can't unless you have information about all three sides. For number 10, again, you're just going to keep doing the same thing. 43.2 over 12 would have to be equal to 18 over 5, which would have to be equal to 54 over 15. So we're going to check our numbers. 3.6, 3.6, 3.6. So yes, so we know that triangle TYR is similar to triangle APR. I already talked about 11. 12, we know that 8 over 20 would have to be equal to 6 over 16, which would have to be equal to 9 over 24. So 8 divided by 20 is 0.4. Nope, these are not similar. So now we're going to look for side, angle, side. If we can prove these triangles are similar by side, angle, side. So I can get my angle here because of vertical angles. And then I can see that 12 becomes 24 by multiplying by 2. Wait, no. Nope. 12 becomes 48 by multiplying by 4, as does 6. So these are similar. So triangle SER is similar to triangle GEF. So again, we get the angles because of vertical. So we're going to check the proportion. So 0.625. So it is true that 27.5 over 44 is equal to. So we know that triangle FJS is similar to triangle FYP. We have parallel lines, so I know that I have corresponding angles. So we have to check the sides. 33 divided by 54, 0.61 repeating. 22 divided by 36 is 6.1 repeating. 0.61. Yes, so we have triangle MPC is similar to triangle PQR. So they give us a corresponding congruent angle. So we are now checking the proportion. So 35 over 50 would have to be equal to 31.5 over 45. So 35 divided by 50 is 0.7. 31.5 divided by 45 is 0.7. So they are similar. So triangle FGE is similar to triangle KHJ. So last two. So there is a same angle. So we got the angle. So we're checking 15 over 45 is equal to 14 over 14 plus 28, 42. So we have 0.3 repeating, 0.3 repeating. So yes, so we have triangle WQR is similar to triangle WSZ. So finally, we have the same angle. So now we're going to check 30 over 39 would have to be equal to 27 over 34. 30 divided by 39, 0.769. These are not the same, so they are not similar. So your homework now is not telling you which statement, which sort of criteria you need to match. So you have to look at the information that it gives you and sort of match it up there. So here, for example, 25 over 55 would have to be equal to 20 over 44, which would have to be equal to 17 over 37.4. So if we check, 25 divided by 55 is 0.45 repeating. 20 divided by 44 is 0.45 repeating. And 17 divided by 37.4 is 0.45 repeating. So these are similar. So if I write my triangle statement, TSR is similar to PQ. Wait, no. Yes. No, it's similar to QPN because we went from largest to second largest, so largest to second largest. So here we can prove it. So this one was side, side, side. This one we could do angle, angle. So triangle EGF is similar to triangle JGH. Here we have an included angle, so we would just check 30 over 38 is equal to 28 over 35. 30 divided by 38 is 0.789. They are not the same, so they are not similar. Here we're looking, so here we're going to see if we have two congruent angles. So 180 minus 106 minus 29. This would be 45. So yes, these are by AA. So triangle ANF is similar to triangle SEH. We have vertical angles. So now we're checking 48 over 60 would have to be equal to 56 over 70. So 48 divided by 60 is 0.8. 56 divided by 70, 0.8. So yes, these are similar by side angle side. So we have triangle QNR is similar to triangle LNM. So now we're going to look to see if it's side, side, side. 54 over 96 would have to be equal to 45 over 80. So let's check that first. 0.5625, 0.5625, so let's check the last one, 36 over 64, 0.5625. So yes, by side, 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 we can say that triangle ECD is similar to triangle MLM. So here I have parallel lines, so I can say that I have corresponding angles here. And let's see, is there any other angles that I can say? Well, if I extend out my parallel lines, I don't think there's any other angles that I can say. So I'm going to say no, you can't prove these. So here we have an included angle. 21 minus 6 is 15. So 15 over 21 equals 10 over 14. 15 divided by 21 is 0.714. These are not the same, so these are not similar. Here, yes, angle, angle, TUS is similar to VUW. So we have a congruent angle. We're now going to check. So 28 over 20 is equal to 21 over 15. 1.4. 1.4, yes, so side angle side. Triangle HKD is similar to triangle APE. Vertical angle 95 over 72 would have to be equal to 87 over 68. 1.3194 repeating. Nope. Not similar. Okay, we have an included angle. So I can do 30 over 42 is equal to 25 over 35. These are the same, so side angle side. Triangle SRT is similar to triangle PRQ. So if that's a 90-degree angle, then that's a 90-degree angle. So we would have to check 16 over 26 is equal to 21 over 32. No, wait, I'm messing that up because I have to do biggest with biggest. So the biggest one here is, so if we say this is new and this is original, 32 over, oh, so it's 26 plus 16, so 26 plus 16 is 42, is equal to 16 over 21. It's 0.76. 0.76, so yes. So by side angle side, triangle, so we said that these two are, so we have BEA is similar to triangle DEC. If PR bisects QPT, so we have two congruent, wait, nope, we don't have two congruent angles yet. QPT is 42, so each of these is 21. So now we have to double check. 180 minus 21 minus 102 is 57. Nope, not similar. This tells me that I have a pair of congruent angles, but then I have two sides are the same. Okay, so if two sides are the same, So I have two isosceles triangles. So yes, these would be similar by AA, BRM, similar to ZPL, right angle. And this one would not work because that is not sandwiched, so no.